Hey, hi guys, welcome to DSC Mindset. Today we'll talk about find minimum in rotated sorted array, right? Let's try to understand the problem statement very quick. Suppose an array length is given and sorted in actually ascending order, which is actually rotated between 1 and n times, right? For an example, if we'll try to understand that, we can see that the array is given 0 to 7 might become after rotation 4 5 6 7 0 1 2, since it was rotated 4 times, and it can also become 0 1 2 3 if I'm just rotating whatever the length is given of the array with the same length. If you're rotating that, it will come back to original one after rotation, right? We'll try to understand more in details, and here is an example. If we try to understand this example, we have like 3 4 5 1 2. So if you look at that, the minimum element is nothing but 1. So basically it was actually rotated 3 times, but the minimum is 1. If you look at in second example, minimum is 0. If we'll look at in third example, the minimum is nothing but 11. So what we're trying to do, we're trying to find the minimum. Let's look at that. Let's try to understand it. So here, if we look at that, how the things is kind of happening. So in that case, if we'll try to understand this portion, so we'll try to find the minimum here. So okay, so we have 3 4 5 1 2, right? What we are trying to do, we are saying that minimum is 1. So the original array was 1 2 3 4 5. So if it is 1 2 3 4 5, so we are trying to rotate 3 times, means we are trying to say that, let's suppose if we are rotating 1 time, so 5 will come here and this portion will come here. So basically it will become 5 1 2 3 4. Next time it will become 4, right? 4 will come here, 5 will shift, 5 1 2 3. Again if we try to rotate, so it will become 3 4 5 1 2. So that's actually what they are talking about. So input is given here 3 4 5 1 2, and that's why we are trying to rotate it. Basically it's a sorted, but actually it's rotated sorted, and we have to try to find out the minimum. Similar in this example and this example. Let's try to think about that, how and what can be the possible way to find the minimum. Let's suppose if I'm trying to say that in a simple way, straightforward, if I'm trying to say that given u without any rotation, or maybe rotation with the length of the array, will come back to the original one. If I'm trying to say that 1 2 3 4 5, and if I'm saying that this is sorted, what is the minimum? So simply the person can return this one, right? So this is the minimum. But since it is rotation, right? Let's suppose if I'm having the element rotated one time, so I'm saying that 5 1 2 3 4. So what could be minimum? So here it can be challenges, right? Here it can be challenges. Let's try to understand that what can be the challenges here and how actually can we find the minimum. So let's try to understand. This is the given something nothing but the original array. It's been rotated one time. So in this scenario, if you look at that, since it is rotated, right? So so this is, let's suppose if I'm trying to, if we're trying to apply the binary search, so this is, let's suppose, low, and this is something like high we are talking about, right? In that case, let's suppose our minimum is coming here initially, right? And if you're trying to solve the problem, right, again minimum will get changed. So finally, let's suppose your minimum is coming here, or maybe your minimum is coming here at this particular place, right? There's a possibility. Means what I'm trying to say that if mid, right? So there is a possibility that your minimum is coming here, or there is a possibility that your minimum is coming here. So let's consider one of the possibility. I'm just trying to consider one of the possibility that minimum is coming here. Not minimum, basically. Sorry, I'm talking about mid. If mid is coming here, so I can say that if mid minus 1. So let's suppose mid is here, and if we'll talk about mid minus 1 is nothing but this part. If we'll talk about mid plus 1 is nothing but this part, right? Next element. So if we'll say that the previous element, like mid minus 1, let's suppose 5. Basically it's like something that mid minus 1, the whatever the element we have, let's suppose array at mid minus 1, if it is actually kind of greater than the mid, right? Array at mid. So this I can be sure here. I can be sure here that mid will be, array at mid will be the minimum, right? Why? Because this is sorted, right? So that's the reason this is the one of the possibility where we can be sure that this will be minimum, right? And there can be another possibility. Let's try to think about the another possibility. Let's suppose I'm saying that your mid is actually here, let's suppose, right? Let's suppose I'm saying that this is your mid. You have low here and you have high here, or maybe obviously low and high will get changed. Finally, let's suppose your mid is coming here. So if we'll try to compare from the previous element only, because from low and high we'll try to move to the different direction wherever you want. But the thing is that, let's suppose if I'm trying to compare 5 from the next element or previous element, if I'm trying to compare with this one, so if this is higher, right, I can say that array at mid is actually kind of higher, right, than this one, means array at mid plus 1. If this is the case, what we'll do, we'll say that this is the right answer, so we'll return it, correct. But why I'm saying that this way, I can't say that like 3 is greater than 4. There's no possibility, right, in that case. So we are not going to do anything else, because this is something like rotated, no, and obviously if it is rotated, so possibility is a maximum like the next element, like mix, let's suppose this is a mid plus 1 and this is mid, for an example. So this will be always greater than previous one, since this is. But there is a situation that, let's suppose that this next element is greater here than previous, this element is greater than previous, this element is greater than previous, but this element is not greater than previous. But I will say that previous element is greater than this. That means I'm saying that if mid is here and if it is greater than this, so I would say that this particular things is right answer. That is what I'm writing here. In that case, if I'm saying that, for an example, if I'm trying to say that, let's suppose this is next element is greater, so this is lower, this is greater, this is greater, this is greater, right? But if this is lower and this is greater, then that's not the answer. But this is greater and this is lower, then we can say that this is the answer, right? Means I'm saying that this is greater, means I'm saying that array of mid minus 1 is greater than this. I'll try to return the answer, right? That is what I'm trying to say. So this is whole logic. If it is not found, we'll try to kind of traverse it. How will traverse it? Let's suppose I'm saying that my low is whatever we are talking about, low, right, is basically lesser than mid, right? Let's suppose in few of the scenario this is low and this is let's suppose mid, right? If this is the case is coming, right, I'm considering that this is low, index number 1 is low, right, and this index number 3 is something like mid. So what we can do in that case, mid is greater, obviously it should be. So where we'll search? We'll search to mid plus 1 side, right? Right? Because we have to move the mid to the next one, because this is something like low I'm saying. This is something like mid I'm saying. We'll not be able to find out. We'll try to search in different direction. That is what we can do. Let's try to understand that how the things is working in a more details. Here is a code for it. If we'll try to look at here in this particular things, so what we are actually kind of trying to do that, we are trying to say that here we are saying that low, here we are saying that this is high, and we are trying to compare it. If this is the case, low is less than or equal to high, then we are trying to say that just return the low, because this is something like sorted, straightforward condition, right? Now I'm trying to find the minimum mid, right? So to find the minimum, basically what I'm trying to say that I'm saying that num at mid minus 1 is greater than mid, right? Num set mid, then we are trying to return. That's what we have discussed, and we are trying to put this condition. Why it's required? Because this is something like boundary condition, right? Let's suppose our mid is coming at very start, at very beginning. For an example, if we'll talk about here, so let's suppose if you are having 1 2 3 4 5, right? So in that case, this condition will get lied and this will return the answer. But in some of the situation, I'm saying mid minus 1, right? So mid minus 1 may be out of bound, right? Let's suppose we have 5 1 2 3 4. So this is mid minus 1, right? Let's suppose, and this is mid. But if I'm trying to do the minus, right, let's suppose here is a mid coming. If I'm trying to do mid minus 1, we don't have any element. So to handle this, we are trying to put this particular things. Low should be always lesser than mid, right? And this is the condition where we have discussed it before. So this is the condition what we are trying to do it here. we are trying to say that mid is greater than value at mid as is greater than nums at mid plus 1. That's what we have discussed here, right? This particular portion, right? So, and also we are trying to make sure that it is not out of boundary. So since we are trying to compare from mid is greater than mid plus 1, we are trying to go compare it. So make sure that mid plus 1 is not out of boundary, it's not at the last index, so that we are trying to say that whatever high we have, it's always lesser than mid, so that we have something, before mid is before high only, right? In that case we are handling it. If it is not, otherwise we are saying that if low is less than mid, we are trying to say low, let's move to the mid plus 1, else we are saying that mid minus 1, right? Low is lesser than mid, right? It means, just to cover up a test case, let's suppose if we'll try to do it here, let's suppose we have 1 2 3 4 5, right? Maybe let's try to rotate one time, 5 4 3 2 1. I'm saying that let's suppose low is here, right? Low is here, or maybe I can again, let's suppose do it little bit more. So 1 will come here, so 1 5 4 3 2, right? That's what we are doing here, 5 4 1. This example we can take, because what we are trying to do, 1 2 3 4 5, 5 will come here, 1 will go here, 5 4 3 2, right? 1, sorry, I have written something wrong, 1 second, let me cancel it out. Basically there is a rotation, right? 1 2 3 4 5, so 5 will come here and everything will get shifted. So 5 1 2 3 4, again this will come here, so we'll say that 4 5 1 2 3. That's how we are happening. So basically we have 4 5 1 2 3. Let's suppose if I'm saying that 4 5 1 2 3, in that case if I'm saying that low is lesser, let's suppose this is something like low is coming and this is something like mid is coming, right? Or maybe let's try to little bit more, 3 4 5 1 2. So if let's suppose low is here, right, and mid is here, and if it is sorted, right, this condition I'm trying to see that. So low is here, which is nothing but the low is lesser than mid, right? I mean 3 is less than 5. So in that case what I'm saying that low should be mid plus 1. So this low should be mid plus 1, means it should be here. So low should come here and high should remain here. Now we'll try to find the minimum over here, right, in this portion, and that's right, because we can't find it here in this particular scenario. So that's the reason we try to move into that direction. We are trying to compare low and mid, right, and based on that we are trying to move it. So that's overall solution. Let's try to look at that over here, what we are trying to do it. So for an example, let me show you the code. So this is the basically code for it, and if you see here, we are having low, which is 0, high is actually nothing but length minus 1. Trying to apply the binary search. I'm saying low is less than or equal to high. I'm trying to find out very straightforward condition. If low is less than or equal to high, then return that low. That's the answer, and basically that's minimum. Otherwise we'll try to find the mid. Mid can be low plus high by 2, or also there is another way to find it, low plus high minus low by 2. That's any one we can actually apply, but this is the standard way what is been applied to find the mid, right? And this is the checks, as we can see it here, right? This is the checks which is actually required, right? And what we are saying that if nums at mid minus 1 is greater, then obviously this is the answer, right? Otherwise what we are saying that otherwise this can be another case. If mid is actually greater than nums at basically mid plus 1, then this is kind of answer, right? And yeah, we are trying to put the boundary so that it is not going to cross the boundary. Otherwise we are trying to move it. I'm saying that whatever the element we have at low is lesser than mid, then we are trying to move low to the mid plus 1, else it will be mid minus 1. And if it is not found scenario, this I'm trying to say it's minus 1. So let's try to basically run this particular code. We can see that all the test case is getting accepted. We can try to submit it. Yeah, we can see it's submitted, and we are actually at here. We are having that the runtime is very less, and yeah, that is the efficient solution. That's what we have discussed here. So the complexity here is order of log n, right? Thank you for watching.